Video session. In this video I'm going to do analysis of the bubble sort algorithm, that is the time complexity analysis of the bubble sort algorithm. In the last video we saw the implementation of this algorithm, and this is the code which we wrote in the last video session. Now to do the analysis and to make our thing easier for us to do the analysis, instead of generating the random numbers, I'm going to initialize the random numbers in the array here. Okay, here let's say we are having some kind of random numbers here by the way of initializing, and if I run the program, you can see here the input array is this and the sorted array is this, and rest everything is working perfectly fine. Now the best case for the bubble sort algorithm, you must be knowing that best case means the least number of major operation an algorithm executes, and the worst case means the maximum number of major operations that are carried out by the algorithm. Or in simple words, best case means the least time taken by the algorithm, worst case means the maximum time taken by the algorithm. The best case for the bubble sort algorithm is if the input array is already sorted. For example, if you are sorting the numbers into ascending order, okay, the best case is if the array is already sorted. You can see here the array is already sorted and we are trying to sort it into the ascending order. Number of swap operation is 0 and the number of comparisons is 4. Okay, I would like to here introduce one more variable, which is the integer variable, which is initialized to pass, which actually counts the number of passes the algorithm takes. Because this is the beginning of the pass of the algorithm, I'm going to increment just before that. Okay, pass plus plus. Now here, as usual, I can just make a print number of passes equal to pass. Okay, you can run the code and see here the number of pass taken by the algorithm is just 1. Therefore, the best case for bubble sort algorithm is if the input array is already sorted. Now if you see here how many swap operation, number of swap is 0 because the elements are already in their correct positions, no need to change anything here. And the number of comparison is just 4. You know why? Because the elements are compared pairwise. First these two are compared and then these two are compared, second comparison, in the third comparison these two are compared, and in the fourth these two elements are compared. So therefore the total number of comparisons is 4 if the number of elements is 5. Okay, so if the number of elements is 6 here, if you run the program, the number of comparison is 5. So I can actually generalize here. Okay, the best case is if the input array is already sorted. Okay, so how many number of swap operations in the best case? It is 0. Number of comparisons is, I can say it is n minus 1. And how many passes in the best case? Number of passes is equal to just 1. Okay, so therefore I can say the time complexity of the bubble sort in the best case is order of n, because this inner loop is executed, this loop is executed just once in the best case, and the time complexity of this loop is order of n. Okay, this is about the best case of bubble sort. In the worst case is if the input array is reversely sorted. For example, our algorithm is sorting the input array into ascending order. If the input array is reversely sorted, because it is array is in ascending order, let me make it reversely sorted. 5 4 3 2 1. This is now the reversely sorted array because we are trying to sort the arrays into ascending order. Okay, so if the input array is descending order, which is the reversely sorted array, the number of passes, number of comparisons, number of swapping is going to be maximum. You can verify that here. You can see here the array is sorted, but the number of passes is 6 because there are 6 elements. So I can say the outer loop of this do while is of time complexity order of n because it needs n passes in the worst case. And inside we have a loop of time complexity order of n. So because it is a nested loop, based on our understanding in lecture 1, using the multiplication principle, we have to actually multiply these two big O notations. So in the worst case, the time complexity of bubble sort is order of n square. Okay. The situation is if the array is reversely sorted. This is the situation of the worst case for bubble sort. Now, how many comparisons, how many swap operations, how many passes, we can easily do an analysis by going through this simple example. You can see here the number of passes is 6, because in the first pass the 6 will come to the last position. You can see here at every end of every pass the highest element comes to the last location. In the first pass the highest element 101 comes to the last position. In the next pass the next highest element comes to this position. In the third pass the third next element, highest element, is going to take place in this position. This goes on here. So same thing here. In the first pass 6 will come here, and then 5 will come here, 4 will come here, 3 2 1. So that is why number of passes is 6. How many comparisons are happening? The number of comparisons happening is 30, because number of passes is 6, and in every pass there are n minus 1 comparisons are taking place here. You can see here in the, we wrote that number of comparisons in a pass is n minus 1. So every pass does n minus 1 comparison. So 1 comparison, 2, 3, 4, 5. 5 times 6 passes, which is number of comparisons, is 30. Okay, and the number of swap operation is 15. Okay, so I leave it to you to check why the number of swap operations is 50. You can easily check by doing a hand simulation of bubble sort on this input array. Okay.